Hello. Well, in my last video I had a spot of bother with some microphones. So let's have a look at these. I want to see if it can be modified so that it outputs two channels independently rather than mixes down. I want to sort out a nasty crackling issue and also the connectors on it. And generally take a look inside these because I've got a feeling there's something fishy going on here. Let's have a look. So here's the set, and they look fairly nice in many ways. So you switch it on and you get the channel number and frequencies on the displays here. The receiver has a rather interesting way of telling you. It's got a sort of three lights here. So as these are detected, the lights, it changes colour. So it's got a kind of a blue going on there. I don't know if you can just about see it. And if I switch one channel on, that blue has a green as well. And if I switch the other channel on, that blue has a red as well. And if I switch both channels on, then you see all three colours, which is weird. That's fine, okay. One of the problems I've been having with this is that both channels are mixed down to one, and I want to be able to separate them out at edit time. Furthermore, it comes with this very ungainly adapter, so we plug that into the camcorder. Well, that's a very large thing to have sticking out of a camcorder. So I want to get rid of this and maybe have a stereo jack coming out of here with the two channels independently. Right, let's just have a quick look at these displays. They've got the channel numbers and frequencies on here. And you might think, well, how can I change them? Well, you know what? I think these displays are fakes. Because if I switch it off, you might just about be able to see, if we get the light strong enough, that the information on those displays is fixed. So they're not, as you might imagine, an LCD at all. That's just a light bulb, or an LED, shining through a kind of a filter with those graphics on. Don't like to see fake things like that. Another criticism, well, here's a good thing. Look, I like these threaded jack connectors. So they push on there, and then as it pushes in, it's not just a jack plug. You can feel there's a kind of a spring-loaded thing going on, and then it does up and screws up and doesn't fall out. So that's a good design. This, I like to say proper, I don't know, there's something about this. The clip doesn't seem too good. It kind of works, but it's very heavy. Maybe that's a good thing. So I was getting a lot of crackle and overload when I tried to use these. I found that several things were happening. One was that there's the audio level's too high, so it was clipping badly. Another problem was that it's got some sort of auto record level, so something would start off quiet and quietly get louder and louder, picking up more and more background sound until there was a sound to turn it down. So that's bad. I wondered if I could just set the recording level properly, so I thought I'd have a look at the instructions. But it's apart from a revolutionary breakthrough, I'm not sure there's anything in English here. So the instructions leave me cold. Perhaps if someone can translate that. But I suspect it's not much use to me. 200 millivolts plus or minus 5 millivolts, that might be the output from here, I don't know. This is clearly for a different model. Oh, blending out with technology. Well, didn't do a great job. So let's see if we can, first thing I want to do is have a look in here and see if I can separate out the two channels. I'll switch that off. The way this works is these have AA batteries in them, which were not supplied. Is it AA's? AA's, yes. Professional. I'm not sure it's that professional, to be honest. And in here it has a lithium rechargeable cell. Oh yes, and it comes with a cable. Right, let's see if I can start by having a look in here. to see if I can have a look at get to the electronics really, and then we can see if we can split out the two channels. So first I might do is take this battery out, if that'll do. Yes, it's nice that you can replace that. Oh, and it's nice that it's screwed together as well, so that gives us a fighting chance. Okay, it comes apart nicely, and it's good to see that these aerials then, they're not fake, they are real aerials, real antenna. Should we zoom in a little bit and see what we can find? Well, it would appear that there are two independent receivers here, each with its own crystal. And then are these audio output amplifiers, and the channels get merged together somewhere here? Let's have a closer look at this if we can. Oh, I want to see if there's anything on the other side of the PCB as well. Maybe there isn't much, but let's see what we can find. Now I'm going to struggle to get that PCB out for some reason. Alright, I won't force it. If I can work on this side, I will. Let's just taking a closer look here. Here's the wonderful LED arrangement. So that LED there tells you it's on. Not sure about that blue one there. I don't think I'd seen that one with the cabinet on. Let's just look there. No. That one's hidden. I don't know why there's an LED there that the user can't see. If I switch on the channels, channel 1, that lights up green, and channel 2, that lights up red. So looking briefly at the circuit here, so we have the USB port for charging here. So that would be a charger control chip. We have what appear to be the two wireless receivers here. And then they have their own crystals here. And I was assuming at first that this is the audio amplifier stage for one channel and this for the other. And then not sure what these chips do. But actually that doesn't look right, because these two ICs have different part numbers. And looking at the wiring on them, they look really quite different. All the IC pins on this side are grounded on this one, and they go to various places on this one. So I don't yet really understand the circuitry there. I think the only real answer is to set up some tones on the microphones, and then put them in another room and set an oscilloscope up, so we can go through here, probing through here, and have a look at the signals in various places. So what I've set up here is a Tascam digital audio recorder, and it's got an audio file in it where the left channel is 1 kHz and the right channel is 3 kHz. And I can play that back over a pair of headphones, which can then feed the two microphones. And the separation on that will be fine for the purposes. So this can be in the room next door while we then set up an oscilloscope on the receiver to see where we can find the 1 kHz and 3 kHz test tones. So I have the transmitters next door transmitting 1000 and 3000 Hertz, and we should see on this oscilloscope the combined output from that on this scope when this is switched on. The LEDs here are showing on and the two channels. So if I put my oscilloscope probe on the end, the output here, that should be the 1000 and 3000 Hertz tones. That looks right. Now hopefully I can pick up those two signals further back. We have these two ICs here, this one and this one, which look similar, although they have different part numbers on them. Let's see if we can work out which is the output pin, say, on this bottom one. On this one it looks like it's pin 1, but it can't be if it's the same IC as this one, because this pin 1 seems to go to ground. Well, let's have a look. Yes, it's somewhat noisy ground. So which is the output of this top IC? Let's have a look. Let's just go around the pins then. So pin 1, 2, 3 and 4 all appear to be ground. I don't know why we're getting so much noise on that. So have a look at pin 5, which I think is an input from the radio stage. DC, I think that's DC. DC voltage. Another DC voltage. Nothing terribly recognisable there. Okay, let's try a different tack. Let's look at these two little ICs here. These have got to be associated with the output. These can't, I mean that is the output pin there. But they can't combine them by simply shorting the two together, surely not. I'm not sure what that pin is. Aha! Look, there's the output signal and that's ground. Okay, so I'm not sure what that pin is there. This is the output here. So where does that come from? So there's a 47k resistor there, the other side of which is at ground. Capacitor here with both outputs. That's probably the same signal sat on top of DC. Yes, I believe it is. Which comes from here. And we chase it back to here. Is that one of the tones? That looks like one of the tones, doesn't it? On pin 3 of this IC. Let's go to AC coupled on the input. That's one of the tones. Which tone is it? Let's measure the frequency. That's the 1 kHz signal. So that's that IC there on pin, not pin 3, whatever pin that is, pin 7, is giving us channel 1. Good. Let's look for a similar circuit elsewhere. So that goes via some resistors and capacitors to the output. There's a mixed output there, and that's the 1 kHz one. Okay, but this is the mixed one here. So where does that go? There must be another, probably 222 resistor. Well, there's this 222 resistor here. So I would hazard a guess that the other side of that is the other channel. That'll be the 3 kHz signal there. And it seems to be from the same IC. So this is a 2-channel receiver. Just set the set it to ignore noise. So at this point we have channel 1, and at this point we have channel 2. On the bottom end of these 12k resistors. But both are carrying DC, I'm sure, so they need AC coupling to the output. Or really what needs to happen is this point here, you see you've got your one signal here on this end of the 222 resistor, 2.2k, and the other signal here on the end of a 2.2k resistor. What you need to do, this track here needs to be split, and then all you have on the output circuit is your DC blocking capacitor here, a small capacitor to take out any high frequency. Look, this is the signal here from the two 2.2k resistors. It goes via DC blocking capacitor, so probably about 0.1 microfarads. We can check that in a minute. And then a very small value capacitor here, just to take out any high frequency noise, probably above about, I don't know, 10 kilohertz or something, and a 47k resistor to ground. So we can replicate that for each channel. That seems pretty straightforward. Let's switch this off and see if we can measure the capacitances there. So the DC blocking capacitor here, of course there's the other circuitry might screw up the results, but let's see if we can measure this capacitance here. It's reading 1 microfarad. Okay. And then the capacitor to shunt high frequency to ground, well, it's got a 47k resistor across it, so I don't think it'll read much, but it's guessing at that. I think that's way higher than it really is, because this capacitor here is shunting, resistor here is shunting it. So what we need to do is 1 microfarad DC blocking capacitors for each channel, and then something low to take out any high frequency, so that's probably, oh, I don't know, 10 nanofarads or less, and then 47k to ground, replicated on each channel. We should be able to do that. So here's the circuit as it stands. We've got capacitors, 2.2k resistors, 1 microfarad capacitor, 1 nanofarad for high frequency shunt, and a 47k resistor to ground, and then the output. So I need to cut it here and then take this off to replicate all of the components here for channel 1.
Hello, I'm Max on the right channel.
Hello, I'm Scott on the left channel.
Right, that modification worked quite well. So this is the receiver now with a stereo plug which fits into the side of the camera that this is being recorded on, and outputs to 2 channels independently. The components that I needed for that, the capacitors and resistor, came from this scrap camcorder. It's going to be very handy, this. However, though that receiver side is now really good, I still have my doubts about these, the senders, because they seem to be picking up quite a lot of hiss and hum and crackling and all sorts. And I believe part of that is caused by the automatic record level in these. It seems to be far too aggressive. And I have done some checks with the oscilloscope of what happens if you talk loudly into these, and it clips really badly. So one of the questions is that a problem with the receiver, or the transmissions themselves clipping? Well, I've got a way of testing that later. Then we need to see if I can improve the circuitry in here. And I want to have a look in here anyway and look at this fake display thing. So that can all be part 2. Do please remember to like, share and especially subscribe, and I'll do a lot more content on audio and video technology in the near future. Bye for now.